Today, we're jumping into some really cool research that's teaching AI a skill we all had drilled into us in school, how to show your work. But this is about way more than just making AI a math whiz. It's about cracking open that black box, making AI understandable and, maybe even a little more trustworthy. Let's get into it. Does this question give you flashbacks? Yeah, me too. But it's a great one. Your teacher didn't just want the final number. They wanted to see your thought process, right? The logic, the journey you took. Because getting how you got there is often the most important part. And it turns out that's a gigantic challenge for artificial intelligence. I mean, just look at the difference here. On the left, you've got an answer, 3 halves. Okay, great. But it tells you absolutely nothing. Then on the right, you have the rationale, the whole story. For an AI to spit out that explanation on the right, it can't just be a calculator. It has to actually reason. And figuring out how to do that is the real game changer here. So, let's start with the big why. Why is it so important for an AI to show its work anyway? Well, it all boils down to a fundamental problem in the AI world, and that problem is called the black box. You see, a lot of AIs, especially the powerful ones, they give us an answer, but we have absolutely no clue how they got it. Their inner workings are a total mystery. Now, for some things, that might be okay, but when you're talking about complex reasoning, it's a huge problem. How can you trust an answer or fix a mistake if you can't see the thinking behind it? So here's the thing. Teaching an AI to build that logical chain of steps, what researchers call a program, is incredibly hard. Just think about it. The number of possible calculations and steps it could take is almost infinite. It's like dropping it in the middle of a massive, endless maze without a map. It's just lost. Okay, so that's the problem. And this brings us to the core innovation of this paper, which is a total flip of the script. Instead of getting an answer and then trying to explain it, these researchers came up with a revolutionary idea. Lead with the rationale. This is the magic right here. The model creates the explanation, the rationale first, as a kind of hidden internal blueprint. That rationale isn't just some summary it tacks on at the end. No, it's the very thing that produces the answer. In other words, the explanation is the process of finding the solution. So here's how it works in practice. It's this really neat loop. The AI reads the problem, and then it just generates one simple instruction, like, say, a division problem. It does the math, and then it writes out what it did in plain English. And then it just does that again and again and again, building the explanation one sentence at a time until the final answer just naturally pops out at the end. Now, you can't teach an AI something this complicated with just a handful of examples. You need a library, a huge one, for it to learn from. And that leads us to the first big contribution these researchers made. They built an entirely new dataset with over 100,000 math problems. But here's the crucial part. Every single one comes with a detailed, step-by-step explanation written by a human. You can basically think of it as the ultimate textbook, designed from the ground up to teach an AI how to think out loud. And we're not just talking about simple stuff. This dataset is incredibly diverse. It's got algebra, it's got probability, it even has pure logic puzzles. And that variety is so important because it forces the AI to learn all sorts of different ways to reason, making it a much more flexible and powerful problem solver. All right, so we've got a groundbreaking new method and a massive new data set to train it on. So the million-dollar question is, did it actually work? Let's take a look at the results. And the results are, well, they're pretty striking. The standard AI models, they topped out at about 20% accuracy. Now, since these were multiple choice questions with 5 options, 20% is basically just random guessing. But this new Rationale first model, it hit over 36% accuracy. That's a massive jump. So let's be clear, this isn't just a small improvement. This is the difference between an AI that is essentially guessing and one that is showing the very first signs of being able to genuinely reason its way through a problem to get the right answer. It's a huge step forward. So for our last section, let's zoom out a bit and think about what this all means. Because at the end of the day, this isn't really just about solving algebra homework. It's about something much bigger. So what we have today is a real achievement, an AI that can lay out its thinking on a tricky math problem. But the really exciting part is thinking about where this kind of technology goes from here. Just imagine a doctor using an AI that doesn't just say, this might be the diagnosis, but instead walks them through a logical rationale, pointing to specific symptoms, lab results, and medical studies that led to its conclusion. I mean, what a powerful tool that would be. Or think about finance. An AI that doesn't just predict a stock market trend, but actually explains the chain of economic indicators and global events that make it think that forecast is solid. The potential here is just enormous. And that really brings us to the final and maybe most important question of all. This work is a step away from mysterious black boxes and toward creating transparent partners. It's about building AI that doesn't just talk at us, but can actually reason with us. So I'll just leave you with this to chew on. If an AI can truly show you its work, how much is that going to change how we think about and trust technology itself?